So here we have a quadratic formula, and on the side here, I'm just going to do a little bit of a reminder of how to factor and sort of the expectations for factoring in grade 12. Okay? You will, again, just like in grade 10 and 11, have to factor a lot. You probably won't get as big in numbers. Like when you first learned in grade 10, you get factoring with some really big numbers that makes it a little bit more complicated. Usually in grade 12, the factoring is pretty easy. But it's a good review because sometimes when we have a number in front of x squared, students forget how to factor. Now, what I'm going to expect from you is that you go directly to the answer when factoring. I don't want any long techniques. I want you to be able to go right from the equation to the answer right away. And there's some things that can help you do this. Okay? You're going to have to do a little bit of mental math, but some strategies. First of all, I want you to recognize, and in English, we often use an F to represent the first ones, O for the outside ones, I for the inside ones, and L for the last ones. And you might have heard your teacher in the past say, oh, we need to FOIL this, because it's an acronym for how to multiply it out. Now, this is actually very useful in factoring because whatever your first ones are have to give you your first one. And whatever your last ones are, they have to give you your last ones. The outside and the inside are going to get combined to that middle number. Now, knowing that makes factoring quite easy because if your first one is 2x squared, you only have one option with nice numbers. It has to be 2x and x. If it's going to factor nicely, it has to be 2x and x. And the last one, it's a beautiful number. 1. What are the only things that multiply to 1 that are whole numbers? 1 and 1. So it would have to be 1 and 1. And we haven't had to do any thinking so far. We just chose what things had to be based on what's first and what's last. Now, we need our outside and our inside. Right now, our outside is a 2x, and our inside is a 1x. We need that to make a negative 3x. The only way that would be possible is if both of them are negatives. Double check, if I put both of them are negative, is my last one still positive 1? Yes. So factoring becomes quite easy in grade 12, especially if you're thinking about that factoring is just the reversal of multiplication. And you look at this pattern when you multiply, that your first ones always match up to your first term, your last ones always match up to your last term, and then we have to do a little bit of mental math to figure out what numbers you're going to use so the outside and the inside combine to that middle term. So here, again, I would factor it directly. The only way to get 2 sine squared would be 2 sine theta and sine theta. The only way to get 1 would be 1 and 1. And then I need my outside and inside to make negative 3. These would both have to be negative. Now, we use that idea that if it's equal to 0 and we're multiplying, either the first one's equal to 0, in which case sine of theta would have to be a half, or the second one's equal to 0, in which case sine of theta would have to equal 1. Is a half ever your y-coordinate on your pie plate? Think about quadrangle 1. What family is that in? That's your pi over 6 one. Right? So then here, using your CAS rule, sine is positive in quadrant 1 and quadrant 2. Is your y-coordinate ever equal to 1? Yes, that's right at the top. That's at pi over 2. sometimes you're going to get questions that have sine and cosine in the same question. Initially, this is technically impossible to solve because it's like trying to solve when you have one equation with x and y. You can't solve that equation because you have two variables and only one unknown. In order to solve an equation with two variables, you need two equations, and remember substitution and elimination? So, in questions like this, they won't give you the second equation because the second equation is one of your big ideas. You know that sine squared theta plus cos squared theta equals 1. And in our next unit, we're going to find out that equations that use trig functions that are always true, like sine squared theta plus cos squared theta is 1, is always true. It's called an identity. So that's our whole next unit is all going to be on identity. But if I know that sine squared theta plus cos squared theta is equal to 1, I can get cos squared theta by itself by subtracting sine squared theta on both sides. And then I can use substitution. So I can rewrite my question, which is negative 3 sine theta minus, and instead of cos squared theta, I can substitute in 1 minus sine squared theta. This negative sign, of course, would get distributed to both. So I would get a positive sine squared theta. I'll write that first so that we're getting ready to factor. I still have minus 3 sine theta. And can you see that you're going to have a minus 1 and then another minus 3, which will give us minus 4. We're going to check if we can factor this. Of course, if you can't factor something, you're going to have to use the quadratic formula. And the quadratic formula is on your formula sheet this year as well. Although it would be a good thing to start memorizing so you have it ready for AP Calculus next year. Okay, only way to get sine squared theta would be sine theta and sine theta. Now 4, the last term is 4, there's some options there. It can be 2 and 2 or 1 and 4. But we need the outside and the inside to make 3. Can you see if you choose 2 and 2, your outside's 2, your inside's 2, you'll never make 3 with 2 and 2. It's going to have to be 1 and 4. Now we need to get a negative 3. How could I get a negative 3 with an outside of 4 and an inside of 1? I would need my outside to be negative 4 and my inside to be positive 1. And it's very important. In fact, it's a really good strategy for factoring. Whenever you factor, to check your answer to make sure if I multiply that out, it's correct. If you do that, right, now I check sine times sine is sine squared. 1 times negative 4 is still negative 4. My outside negative 4 sine theta plus 1 sine theta gives me negative 3 sine theta. Question?
How did you get sine squared?
How did I get sine squared here?
Yeah.
I got it from the green part. Inside was a negative sine squared, but it got multiplied by the negative out front, becoming positive sine squared. And I wrote that sine squared theta first so that it would be ready for factoring. But yes, what I was saying, it's important to check. In fact, if you can't factor something, a really good strategy for factoring is make something so the first ones work, something so the last ones work, even if it's wrong, and check it. I guarantee that if you make the first ones numbers that work, the last ones numbers that work, and check it, and it's wrong, by checking it, you will come up with like a strategy, be like, ooh, maybe I should switch this. And then you'll figure out what is right. How did I get rid of the 1? I put this negative 1 and this negative 3, because they were like terms, together to get negative 4. No, but these, like, when I tell you, you're like, oh, now it's obvious, right? But before you see it, it's really confusing. So those are good questions to ask, right? If you're unsure where a number comes from, ask that question. Because sometimes you're like, oh, now it's obvious, but it wasn't obvious at the moment, and if you're confused, that's gonna be a problem for moving forward. Yeah.
So how many marks is this question due? Because all the factoring doesn't count as marks, right?
Right, so they would actually, using the identity, that's the big idea, plugging this in would be 1 full mark, because that's something that's new, okay? This idea of factoring, they probably wouldn't give you any marks for. Sometimes they award a half a mark, like just a little bit of, you did some work, sometimes they'll award that half a mark. But up until this point, where you get sine of theta equals -1, and sine of theta equals 4, there might be no marks. So we got 1 mark for this. Now, is sine theta ever -1 on your pi plate? Yes, that happens. At 3 pi over 2, they would give you a full mark for this, because this is new. This is a non-calculator question, we run into a problem. It's a non-calculator question, and 4 is not on your unit circle anywhere. If it's not on your unit circle, how come you can do this without a calculator? There's a formula, well, not with sine and cos, you'd have to like do sine inverse on your calculator. When things aren't on your pi plate, usually you have to go to your calculator and do a sine inverse and get a reference angle. But this one, even though it's not on your pi plate, it's still a non-calculator. No, it doesn't work out that way. That's a good idea, right? The idea that if sine of theta equals 1 is pi over 2, can I just multiply it by 4? No, it doesn't work out that way.
Isn't 3 pi over 2 on the?
Yes, so this side is on the unit circle. I'm talking about the right-hand side with the 4. There's never a 4 on your unit circle. Now, if you went to your calculator, it might give you a hint. So I'm going to try it on my calculator to see if I can get a hint from this. I'm in radians. We'll clear this out. Maybe. Maybe my calculator won't give me a hint because it's frozen. We'll try pushing a button. No. How about this button? No. So let's say I pretend that I type the right things into my calculator and I get sine inverse of 4, and after I do that, it says error. Kind of, oh, look at this. Sine inverse of 4, error. How could I have known it was an error without my calculator? This side is going to be not possible. And it goes back to grade 10 math. If sine of theta is 4 over 1, can you draw me a triangle with theta with the opposite side 4 and the hypotenuse 1? Like, that makes no sense. The hypotenuse is always the longest one. Okay, so we're going to get questions without our calculator for sine theta and cos theta if that number is ever bigger than 1, also less than -1 if it's a negative number, like -3 would also be not possible. Then you can just right away write not possible. And when I show you, oh yeah, sine of theta is opposite over hypotenuse. Anytime you have sine of theta, you should be able to draw a right angle triangle that represents that. If that doesn't work, it's going to be not possible. Okay, first of all, this is not equal to 0, so we always have to bring things over and make them equal to 0. Second, when I go to factor this, my first one is more complicated than normal. Most often in grade 12, you have no options. Your first one's easy to do. But this one we have options. Can you see it could be 6 sine theta and 1 sine theta? Or 3 sine theta and 2 sine theta? We have options. Options make it difficult because you might choose the wrong option. So I actually, in this one, I'm like, okay, I'm going to defer figuring out my first ones till a little bit later. Maybe my last ones are easier. 1. What two numbers multiply to 1 that are whole numbers? That is no options whatsoever. It has to be 1 and 1. And if I start with the last ones, 1 and 1, now mental math, you might be able to see more easily. Should it be 6 sine theta and sine theta, or 2 sine theta and 3 sine theta? If I use 6 sine theta and 1 sine theta, can you see that your outside is 6 and your inside is 1? Does that ever make 1? Adding or subtracting? No, it makes 7 or 5. So 6 sine theta and 1 sine theta is not going to work nicely for me. But 3 sine theta and 2 sine theta, well, then my outside's 3 sine theta, my inside's 2 sine theta. If I was subtracting, that would work out nicely. I would need my 3 sine theta to be positive and my 2 sine theta to be negative. Double check it. Do I still get a negative 1 at the end? Do I still get a 6 sine squared theta? Everything works out nicely. Now the difference in this question is this would be on the calculator part of your exam or on a test. Part of it you can do without a calculator. So if I solve what would make each of those 0, the first factor, if it's equal to 0, then sine of theta would have to be 1/3. And in your brain, this is what I'm going to write. You wouldn't write this down, but this is what your brain is solving. That one's equal to 0. How could I get sine theta by itself? Can you see that you could move the 1 over, positive 1, and divide by 3 to get 1/3? Okay? You're going to just directly write sine theta equals 1/3. That blue part is going to be mental math. But if you're wondering, Mr. JR, how did you get that 1/3? Well, I did a little tiny equation solving in my head. Same thing for this one. I was like, okay, if 2 sine theta plus 1 has to equal 0, how would I solve for sine theta? I move the 1 over to get negative 1, and then divide by 2 to get negative 1/2. Are any of these on your pie plate for a y value? A half is, but a third isn't. So with the half, this we can do without a calculator. We can say, I know that's part of my pi over 6 family, and since it's negative, sine is negative in quadrant 3 and quadrant 4. So that side I can answer without my calculator. So on a calculator question, they will say, hey, if you can do exact answers, we want exact answers. Do as much as you can without a calculator. However, if you can't do it without a calculator, what do we do now? So 1/3 we can't do without a calculator. So we're going to need to find our reference angle first by doing sine inverse. And whenever you're finding a reference angle, you only use positive numbers. They were positive already, but I'll go to my calculator. Sine inverse of 1 divided by 3. I make sure that my mode is in radians. I can see radians on the top of my calculator because this question's in radians. So when I push enter, I get a reference angle of 0.3398. And I'll put ... because we don't want to round our answers until the end. Now, since sine of theta is positive, we would find an answer in quadrant 1. And if it doesn't say what to round to, you would round to 3 decimal places. So rounding 0.3398 to 3 decimal places would make this 0.340. And my other answer is going to be in quadrant 2. So in quadrant 2, I would go to pi and minus my reference angle. So I can either highlight it or use my answer button. That way I don't round early, and I get 2.802. So my final answers, these ones are to 3 decimal places. These two are exact values. Okay, that's the last question on there. I'm going to add one more question just to practice the quadratic formula, because it does come up. So let's say you're solving a quadratic equation. And you can't factor it. How can you tell that you can't factor it? Well, you try. Here, this is a good way to find out you can't factor it. If you try, the only way that I'll get tan squared would be tan theta and tan theta. The only way that you could get 3 is 1 and 3. The outside is 3 theta. The inside is 1 theta. Does 3 tan thetas and 1 tan theta ever make 1? No. So I just put a big X through it. I tried. The only thing that was possible doesn't work. So now I go to my formula sheet, and on my formula sheet it says for ax squared plus bx plus c equals 0, x is equal to negative b. Here's your quadratic formula. And this is important to do and to practice because there are a lot of little notation errors that students make in this question. Okay? So here's our formula from our formula sheet. It's for x squared. Do we have x squared? No. We have tan squared theta. So in the formula it says x equals, what will we write instead of x equals? We have to write tan theta equals negative b, well b is what's in front of the second one, plus or minus square root b squared, which is 1, minus 4a in front of the tan squared is 1, and c is negative 3 over 2 times a. And so we get, if I simplify this, tan of theta is negative 1 plus or minus the square root of 13 over 2. And because of the plus or minus, I'm going to write it out 2 separately, one with the plus sign, and one with the minus sign. And split my page in. Is negative 1 plus the square root of 13 over 2 on your pie plate? No. We have to use a calculator here. So we're going to need to find our reference angle. And actually with a calculator, sometimes it's helpful to type this in because
Would the students who are donating blood and on shuttle 1, please go to the library conference room now? That's the students that are donating blood today and are on shuttle 1, please go to the library conference room.
it's going to be nice just to see that as a decimal, to notice it's positive. If tan is positive, it's in quadrant 1 or quadrant 3. I'm going to find my reference angle. And it's also important to notice that that's positive because when you're finding your reference angle, you have to use positive answers. So if I do tan inverse of this, there is my reference angle, 0.9161. Dot, dot, dot. So my actual answers for theta here are 0.916, and we find it in quadrant 3. We would do the same thing on the other side for the negative values. But I'll let you finish it from here.